Hello, this is a demonstration of CloudFuzion 3D from Excellion. CloudFuzion 3D allows the seamless automatic integration of internal render nodes with external render nodes at another location. In this case, we will use Amazon EC2 render nodes for this demonstration. In simple terms, we're going to automatically add render nodes from the cloud to my own internal render farm here in-house. We are fusing internal and external render nodes using CloudFuzion. Most importantly, no VPN is needed. In our next drawing here, we have a depiction of what we're going to do. We have our internal render nodes, which you can see, which also can be called a private cloud, managed by Infusion. We will now involve CloudFuzion, and its role will be to manage our cloud compute nodes, our render nodes, start and stop them, and automatically involve them in the rendering process without any further user action required. Again, for this demonstration, we're going to use compute nodes or render nodes on Amazon's EC2. We also support this on Microsoft Azure and any other grid or cloud computing platform that's out there, or at another company location without a VPN. So we're going to now jump to our CloudFuzion desktop. This is what we will use, our management platform, to manage and control all this process. We have three windows here: compute node information, active run information, so what's in the render queue at the moment, and then we have completed run information, which is really the same information as the active runs, but all completed. So if I go back to our compute nodes, we have 6 running at the moment. We have a range of machines involved. Bellagio is an external render node at another company location. Palazzo and Aria are internal render nodes here inside our office, our studio. And the nodes that begin with IP are actually cloud-based render nodes that we have engaged in the rendering process already. So we're using 3 cloud-based render nodes to help with my render queue. And again, Aria and Palazzo are internal-based machines. Okay, so let's have a look at the run information. So again, this really depicts what's on the render farm at the moment. Active runs, we call it. It highlights various attributes. These are Max and After Effects jobs, and there's a lot of frames to be rendered. And at the moment, the workload is being shared across the compute farm. So everybody's sitting at priority 50. You might notice in the center priority window. The bottom, as we mentioned before, is all the completed run information. So let's talk about the application support. CloudFuzion is very robust in its application support, and again, for cloud-based render farms, that's very important. Blender is an important application for us, heavily used in Europe. Of course, we support 3ds Max 2012 from Autodesk, Adobe's After Effects, CS5, Maxon's Cinema 4D, R12, of course, and then various other applications in use across the industry, Fusion, Lightwave, of course. Maya from Autodesk, support 2012, and also the ability to send Maya MI files to our cloud-based nodes. Nuke is supported, along with RealFlow and Rhino. Houdini's Mantra renderer we support. Shake's still used, so we still support Shake, and Softimage, of course, and 3Delight, which are RenderMan compatible renderer with using RIB files. So we will go ahead and launch a 3ds Max scene onto our render farm. So we will go ahead and launch our submission template. Our scene is on the network, so we'll pull our chess set scene from across the network and dispatch that to the render farm. You can see we have version selection, so we continue to support all the versions of the product. For this one, we support 2012. But our customers still have some of the older scenes in place, so we'll go ahead and submit that. We have a confirmation window here. Another important area is identifying scene assets. This is where we actually read the scene, determine what assets are there, find them, and then take them with us to the render farm and the render nodes, whether it be here internally or cloud-based render nodes. So the whole scene comes along with us to the cloud. This is run number 50, and again you can see that we've identified where the assets are in the network on various machines and pulled them with us to the render farm. So let's jump back to our CloudFuzion desktop. This is run number 50. It's waiting for resources because the resources are still involved in the other work on the render farm. We'll go ahead now and launch an After Effects job. Excuse me, scene. Process is really the same. So that's our After Effects job submission window. Scenes on the network. We'll run 200. That's our composition name, CS5. Again, similar process, confirm and submit. And we now have run number 51 submitted to our render farm. So if we jump back to our CloudFuzion desktop now, we can keep tabs on what's happening there. So here we see run number 51, which we've just launched, and run number 50. So Max and After Effects runs. So I think at this stage, let's start reassigning the priority or the compute pool, render pool to our run number 50. So by changing the priority here, as you can see, we've gone from 50 to 100. It allows us to dynamically reallocate the resources to this particular run because we deem that's most important and has to get out first. And that's a very simple way to do it. So you can see now that the render nodes are starting to migrate over to our run number 50. So now the next step is let's add some compute nodes. So using our cloud controller that's designed and built into CloudFuzion, we can very simply with one click launch render nodes. So in this case, let's go ahead and launch 10 nodes. Again, all managed and controlled by our cloud controller here inside CloudFuzion. This, of course, could be 100. It could be 1,000. It's really a one click, as many nodes as you need to get the job done. And again, all managed and integrated out seamlessly by CloudFuzion into the rendering process and the render farm. Okay, so now we've just added 10 nodes to the render farm. So if we pop over to our node window, here you can see we have 6. Our new nodes will start showing up here and get immediately involved. They'll show up as executing, which means they'll be actively involved in running the job, and it's really just as simple as that. And we can see that run number 50 is starting to get more compute power, render power assigned to it. Okay, so here's our new 10 nodes, just showed up. The process usually takes 3 to 5 minutes, or excuse me, 5 to 7 minutes, depending on what's happening in the latency on Amazon EC2. So we have a mix of 4 core render nodes on the cloud with our internal machines, Palazzo and Bellagio, and Aria, of course. So now you can see we've got 15 compute nodes or 15 frames executing in parallel, which is really what we need. So if we just now have a quick look at what we call the job list, which is actually the frames being rendered. So you can see Palazzo and Aria were very involved in the beginning, but as our cloud nodes got started up, they became quite involved in the rendering process as well, and now they're all working on the scene. Palazzo and Aria, again, are internal render machines. So again, all of our cloud-based render nodes are actively working on frames on the cloud. Another thing to notice, we've color-coded our what we call our job list. So green is executing, black is done, and blue is waiting. So let's have a quick look at the output directory. Again, we launched this run or this scene from our local machine/network, and my results are coming back to my local machine in the work directory for run number 50. So here's all my images, and again, CloudFuzion is handling all of this. In this case, my render nodes are sitting on an Amazon in an Amazon data center on the East Coast, and all the results are coming back to my local C drive or D drive or wherever. We've just noticed an Amazon node goes down, or has just gone down. Excuse me. Amazon is not as stable as we might like, so occasionally our render nodes go offline, and we're not sure if this is related to EC2 networks or virtual instance issues. But CloudFuzion, because it's fully fault tolerant and redundant, knows what work went to that down node and reschedules it to other machines. So as these nodes come and go, CloudFuzion doesn't mind being completely fault tolerant. It just really handles that nicely. So let's go ahead now and demonstrate how to shut down nodes. We'll assume that we've got close to the end of our big run, and we don't need our large quantity of nodes. So we'll go ahead and launch our cloud controller again. Let's go ahead and shut down a dozen nodes. Simple as just entering the node count in there and hitting stop nodes. So it's a very easy, simple start-stop process. And now we have, we'll see our 12 render nodes have been told to shut down on EC2, and we will start showing those showing up in here as red, as being down. So of course, because Amazon is a pay-as-you-go service, as soon as the nodes are stopped, the charging also stops. The clock stops on the credit card, so to speak. So now we see our nodes are down. Again, an important piece is all of the work that was scheduled for those nodes that have just gone down automatically gets moved back to our internal render nodes. So no matter how many you start or stop, no work ever gets lost, no frames get lost. Again, fully fault tolerant, and that's really, really important. And again, easily start up and shut down, easily managed. So here's what we've done to go over what we really did. We connected our internal nodes using CloudFuzion to our Amazon EC2 nodes, and with one click, stopped and started our nodes, and they automatically get involved in the render process. And again, we do that with Azure as well. So just to summarize, CloudFuzion enables on-demand rendering very easily by integrating internal and external resources. One management platform to do all of this, which is most important. One workflow. So as the scenes are leaving our network here, going to the cloud-based render farm and back again, nothing else needed. And you can see that CloudFuzion very easily and automatically bridges our internal rendering resources with our cloud-based resources, all in one go. So if you'd like some more information, please visit our website, www.cloudfuzion.com, and thank you for your time in watching our demonstration today.